All right, here we go with 4.1, part 4, take 2. We did a sound check. The last one did not have any sound, but I'm not going to blame somebody here. Okay, anyway, part 4.1, part 4. Okay. So this is where we look at the other three trig functions and their graphs. So we're going to take a look at cosecant, secant, and cotangent all together are here. All right, so normally I would do cosecant and secant first, but I think I want to start with cotangent since we just left off with tangent. Okay, so basic graph. So the cotangent graph. Okay, so we have y equals cotangent x. So now tangent is sine over cosine, but cotangent is cosine over sine. Cotangent is the reciprocal of tangent. All right, so let's make our table of values for cotangent so we can see how the graph how the graph develops. Okay, so we're going to use 0. We still like pi over 4. We'll do the other quadrantal, pi over 2, and then 3 pi over 4, and then pi, and then 5 pi over 4, and then 3 pi over 2, and then 5, 6, 7 pi, 7 pi over 4, and back to 0, which is 2 pi. All right, so cosine, so we're starting with 0. Cosine of 0 is 1, but sine of 0 is 0, okay? Sine of 0 is 0. So that means that we get 0 in the denominator, which is undefined. Okay, so undefined. Pi over 4, cosine and sine are the same, so it's positive 1. Pi over 2, cosine is 0, but sine is 1, so 0 over 1 is 0. 3 pi over 4, we're in quadrant 2, so cosine is negative there, so it's negative 1. Pi, all right, so pi, cosine is negative 1, but sine is 0. So negative 1 over 0, undefined again. Ooh, I don't have much room here, so I'm just going to write UND. All right. Okay, 5 pi over 4. Now we are in quadrant 3. Cosine is negative in quadrant 3, and sine is negative in quadrant 3. So this will be positive 1. 3 pi over 2. Okay, so 3 pi over 2, sine is negative 1, but cosine is 0. 0 over negative 1 is 0. 7 pi over 4, cosine is positive, but sine is negative. Okay, and back to 0, so we are undefined. Okay, so let's take a look and see what this graph looks like from 0 to 2 pi. All right, so far, okay, so 0 is undefined, pi is undefined, and 2 pi is undefined. So here, here, and here, we are going to have asymptotes. Vertical asymptote here, here, and here. Okay. And then what happens is here at pi over 4, let's see. Let me put the quadrantals down so that we can at least see those. Pi over 2 here, 3 pi over 2. So these 4 are the quadrantal angles. 0, pi over 2 pi, 3 pi over 2, 2 pi. All right. And then we see here at pi over 2 it's 0. 3 pi over 2 it's also 0. Okay. Pi over 4 is 1. 3 pi over 4 is negative 1. And then 5 pi over 4 is 1. and then -1, and then it kind of repeats itself. So here it looks very similar to the graph of tangent, but if you remember, a tangent went like this. Okay, so it's like it reflected over the x-axis. Okay, so cotangent here we also have two cycles. So here, all the way here is two cycles from 0 to 2 pi. One cycle is here. One cycle is 0 to pi. So we see here that it repeats after pi, just like tangent. And so here, pi would be considered the period. Okay. All right, so let's write down our general things about the cotangent. So in general, y equals cotangent x has the graph that looks like this for one cycle. Vertical asymptotes on the ends, 0 halfway in between, +1, -1. Okay, so let's write all of that down. So, endpoints have, and we're going from 0 to pi, endpoints at 0 and pi. And then endpoints also have vertical asymptotes. Vertical asymptotes. Okay. And then halfway between endpoints, we have 0. And then halfway on the left, we have +1. Halfway on the right, we have -1. Okay. And we notice here that it repeats every after pi. Okay. All right, so that's the graph of cotangent. All right, so let's take a look. Let's take a look at cosecant. So, and let's just to emphasize here for cotangent, from 0 to 2 pi, we see like two fully connected, like snaky looking curves here. Whereas cotangent, let me scroll up here. I mean, not cotangent, tangent. Tangent, ignore the purple part, and we see two snakes, except we see one fully connected snake, and then the other one is kind of disconnected. The top half is over here, while the bottom half is over here. Okay, but still from 0 to 2 pi for tangent, we also get two cycles. Okay, so let's go back down here. All right. Okay, so that is cotangent. So let's go ahead and do cosecant and secant. All right, so here, y equals cosecant x. So let's recall that cosecant is just the reciprocal of sine. Okay, so here again, just like cotangent and tangent, we have a trig function in the denominator. So we're going to have vertical asymptotes where that denominator is 0. Okay. When we graph cosecant and secant, we actually start off with um, the sine x and the cosine graphs. So here cosecant is the reciprocal of sine, so we're going to go ahead and graph y equals sine x first. Okay, so that's what we do first. And we do all of the transformations later on when we start getting really fancy with these functions, like if you have to add or subtract or multiply to cosecant. What you do is you do all of those transformations to sine x. And then once you're done with all of that, then you can graph the cosecant. All right, so that was probably a little too much for now, but so we first graph the basic graph of sine x. And because sine is in the denominator, we are going to have vertical asymptotes wherever sine is 0. So vertical asymptotes where sine x equals 0. Okay. And then we're going to, once we have that all done, then we're going to go ahead and plot the reciprocal values. Okay. All right. So let's go ahead and do that. Okay. And we'll graph it from 0 to 2 pi. Okay. And I will do the sine graph with like a dashed or dotted line. And then I'll do the final graph cosecant in purple with a solid line. Okay. All right. So graphing sine, we know that it's 0 at all 3 of these values, right? We know it's 0 here. And then halfway between on the left, it's 1. Halfway between on the right, it's -1. So this is the graph of sine. Okay. So we did step 1. Step 2, vertical asymptotes where sine x equals 0. Okay, so let me do the rest of it in purple. Okay, so right here, this is where sine is 0. So we have a vertical asymptote there. This is also where sine is 0. And right here is where sine is 0. So here and here, we will also have vertical asymptotes. Okay. And then we plot the reciprocal values. Okay, so all of these are points. Like this is 1, and then like this is maybe 0.98, 0.97. Making these up, but they are like somewhere between 0 and 1, right? Right there, it's like 0.5, right? 1/2. Okay, so all of these we will take the reciprocals of. So let's start with this one. Reciprocal of 1 is 1. I don't know any of these numbers except for 1. At 30 degrees, it's 1/2. So the reciprocal of 1/2 is actually going to be 2. Same thing here. Okay. At 150 degrees, the sine is 1/2. So right here, cosecant will be 2. And so what we end up with is actually kind of like a parabola. Okay. And then the same thing over here. Over here at, what is that? 7 pi over 6. It's 1/2. So here it's going to be like -2. Same thing here, -2. And so I have this graph here. Okay. And that's really all there is to it. So y equals cosecant x is the purple. So we always start off with the sine graph, and then we put our vertical asymptotes down, and then we just take the reciprocal. Now, make sure you understand that this point right here at 1 is also a point on cosecant. Sometimes I see students do this, okay? So sometimes I see students do this. They do their sine graph, right? And they do this, they do this, they do this. right? And then they put their vertical asymptotes. Great. Everything's going great, right? And then all of a sudden they do this. Okay. This point right here is part of the graph. So don't draw it off. Make sure you draw it as part of the graph. Same thing with this one. Okay. All right. So because the reciprocal of 1 is 1, the reciprocal of 1/2 is 2. Okay. Okay. All right. And then the same idea goes with secant. So let's do secant graph. Secant graph. All right. So y equals secant x. And remember, secant is the reciprocal of cosine. Okay. The reciprocal of cosine. So we are going to, just like cosecant, we're going to graph the cosine function first. And then we're also going to put down the vertical asymptotes. Vertical asymptotes where cosine x equals 0, because then that makes the denominator 0. So anything over 0 is undefined. Okay, and then we are going to also plot the reciprocal values. All right, so let's take a look. So here I am going to do y equals cosine x in black and dotted. Did I mention that? Yeah. Okay. Y equals cosine x. So we're going from 0 to 2 pi. All right. I need to go a little thinner here. Okay. All right. So we know that we know at the endpoints we have 1. We know halfway in between we have -1. And then we know on the left side halfway between is 0. And we know on the right side halfway between is 0. Okay. So my cosine graph looks like this. All right, so now I'm going to do the secant graph. And that will, oh, it's actually going to be solid. Okay, it'll be solid and it will be in purple. Okay, so step one was to graph the cosine function, which we did. And step 2 is to put the vertical asymptotes where cosine is 0. So cosine is 0 right here and right here. So right here and right here is where cosine is 0. So we are going to have vertical asymptotes right here. This is where it's undefined, so we will not have any points there. The graph will not cross these lines. Okay, and then we'll plot the reciprocal values. So again, the reciprocal of 1 is 1, so we will have a point right there. Over here is 1/2. Cosine of 60 is 1/2, so the reciprocal will be 2. So it's like we have the right side of the parabola looking thing. Okay, so over here, again, reciprocal of -1 is -1. So this will be a point on our graph. And then over here, right over here, it's not halfway between, but at 60 degrees, we have a point 1/2. So now we go down to -2. Okay. And then same thing here, -2. And here you get to see the full effect. And then over here, at 60 degrees reference angle. We have 1/2, so up here we will have 2. And we only have the left side, which makes sense because this whole thing will start to repeat after 2 pi. These 3 pieces will repeat. So we will have a right side starting over here, and that will complete this sort of parabola looking thing. Okay, so these 3 pieces would repeat. So we would have a right side, and then upside down U in the middle, and then left side, and then repeat again. Right side, upside down U in the middle, and then left side, and then repeat again. Right side. Okay, so this will always close that one. Okay. All right, so I believe that is it. Yes, so that is it for part 4. Stay tuned for part 5, a short video on odd and even functions.